Yeah. Okay, so hello everybody. So Sheetal, you're being recorded now. I just meant to make a general statement. So please, all of you, make sure that you receive feedback. Every one of you has received feedback to the research note 1. And I have developed my own rubric where basically each specific rubric item received specific feedback, just to also avoid any confusion for research note 2. Hi, Daryl. I've just been talking about research note 1 and the feedback. Hi. Did you receive the feedback? Are you able to access the feedback?
I had an opportunity to look at it maybe 15 minutes ago.
Yeah.
Because I was working on it.
Yes, I understand. I just want to make sure everybody has access to feedback, because some students, and when I taught this class previously, have told me they were not able to see the feedback that I've posted. And I really want you to see that feedback.
I did see the feedback, yes.
You see it? Okay, good.
Yes, sir.
It's kind of in a rubric system, and I hope it really helps to get a good idea for research note 2. So can you see it?
Professor, as far as the feedback, what I saw was categories and points for all the categories. Like I didn't see anything else other than that.
Well,
I saw the same thing too, yeah.
But you see, for the respective rubric item, for the respective category, you see a comment, right? Do you see comments?
No, not comments. Just the categories, what they contain, and the points for each category.
Okay, is there somewhere a comment section that you can click into? I don't know how it looks like at your end. Is there nothing written on the side? Because that's really confusing. You should be seeing it in something that should be labeled as, but I'm opening it up on my end. View grades details. You should see here, you should see my grading details. You should see grading notes, feedback to learner. Can you not see this?
You talking to me, Professor?
Either one of you.
I only briefly looked at it. I've seen some comments, and I've seen some numbers, so along with the comments. I haven't had a chance to really thoroughly look at them.
But you see the comments. You see the comments.
I see some, yes, I see some wording. Yes, I do.
Okay. How about you, Sheetal? Do you see my comments?
Okay, let me see. Okay, I'm not on mute. Okay. I see, yeah, I see some comments on the side, yeah.
Okay, great. Okay, so good. Just wanted to make sure. So these are meant as comments, essentially outlining what I think are areas for improvement. And so please pay attention to those for the research note too. I didn't enforce them. I didn't grade them very strictly, but I think some certain aspects of it are just important to keep in mind, particularly when it comes to the structure of a scientific paper. So I think it does make sense to kind of start very early to kind of create all research notes and all assignments in the way that you would write the scientific papers, essentially. And I've made comments to that. So it's really, every scientific paper should kind of follow the same outlines. It should have a background, should have methods and results, and a discussion / conclusion. And it's just important that each of these 4 sections gives a home to a certain specific kind of information, where background introduction is basically giving background of introduction of why that research is important, and then slowly going into the thesis statement. And in the thesis statement, you present your hypothesis and you present why and what you did, but only in brief terms. So a thesis statement should not be longer than like 3 sentences, 3-4 sentences, a tiny little paragraph essentially. Whereas in the methods, for example, you would go in very much detail what tools you employed and why you choose to do these methods and utilize these methods to analyze your data. In addition to that, you would also give information of where's the data from, what's the data source, what are the definitions that you use. So if, for example, you used binary data and you dichotomized contiguous data, you would basically define this in your methods part. And also in the methods, you would state which statistic software you used or which other softwares you used. You would state for R specifically, you could even cite R. So if you look in R, you can actually find a citation. So R is basically wants to be cited, and you can find out how to cite it by citation, by clicking on citation. So this is basically the proper way of citing R when you're using R. So you may choose to do that. It's nowadays R is quite mainstream, so you don't need to really cite it in that format anymore. So you can kind of just cite it as the software that you're using. In addition to that, you would also give a version number for the R version that you used. Of note, for the R version, not the RStudio version. And you would also list all the libraries or the packages that you have used. For that reason, that you essentially you want to indicate which packages have you used, and so that your reader understands which packages and possible errors in the packages do apply to your analyses. And usually there are not many errors in the packages, so these packages have been proven and have undergo a review process by our team. So there's actually a foundation for statistical computing that does observe and goes through all the packages before they're being posted on the so-called CRIN, so on the CRAN for download. So there are no errors in there, but in the beginning when R came up and that became increasingly popular, to make sure that editors were comfortable, editors of journals were comfortable with analysis conducted in open source software, the journals actually ask specifically for packages to be cited. So I think this is quite a good practice to keep looking at. Then thirdly, you then embark on the chapter of the results. And in the results, it's very common to kind of always state first as an introductory statement, the sample size, some basic descriptives, which would essentially be the quote unquote table 1. And this table 1 can be done quite easily and can quite easily be done. So there's, for example, there's a table 1 package, which I can actually show you. So the table 1 package, or the Stargazer package that we have been using, table 1 package in R. This is essentially, so that's a package that's basically developed to allow for the computation of table 1, these packages that basically allow you to give an overview of all specific descriptives that you're interested in. Where Stargazer also has really good features. So to show you Stargazer just in brief terms, and we've used it already for linear regression. So if you go into the RMD file, for example, and you're creating this data frame where you have the attractiveness of the bee, and you have the actual likelihood of the bloom to be pollinated by the bee. And if you essentially develop this data frame, this DF, and you go then on Stargazer, Stargazer not only can be used to display linear regression models or logistic regression models, it can also be used to essentially build this text, I believe, to build type 1 tables. So here, for example, if you have here, so you have your data frame containing these sub-objects. And if you use the Stargazer package on this object, this will basically, just with the addition of type text, it will automatically create for you a table giving you the sample size, the means, standard deviations, and you can individualize quite a lot of things. But this is a very simple way to essentially create a type 1 table, table for your research node. So, and in discussion, you essentially go then and you take your results. A lot of you in the results also forgot to add the model diagnostic plots. So we specifically talked about including those in the research node 1. And in the discussion, you would then, firstly, you would take your main findings. So what are the leading findings of your publication, and what did you find in your research? So that would be the first part of a discussion. Then you would go on, and you would, in a second part, you would essentially take these insights, so these principal findings of your paper, and you would discuss them with what had been previously published to the topic. And then thirdly, you would actually go on and you would hypothesize about the implications of your findings, and then briefly talk about the strengths and limitations of your findings, of your analysis, of the analysis at hand that you're presenting. And then lastly, you go towards the conclusion. And that would basically conclude the paper. So I think it's just important to kind of really embrace this structure very early and make sure to keep in mind for future assignments that you will be working on. And this is generally accepted. Good. So this was essentially, and I also wanted to spend some time to go through the syllabus. So this was basically what I wanted to say about the research note. Any questions to any of this? Was this okay? Can you see my screen well?
Yes, I can see it.
Yes, I can see it.
Okay. So then I just briefly wanted to also add that now the release date for class 13 has changed, and that was Tracy suggested that this was only she pointed out that this only will go online on Sunday. It is available now, so you can now already start with class 13, which talks about missing data, with the idea that we can talk tomorrow already about class 13. You can start preparing for exam number 2. Research note 2 was assigned, so this is due next week on Friday. And then we have homework 2 that is due on Sunday at midnight. So yeah, so this was essentially the housekeeping notes. I just want to make sure that we're all on the same page. Then for this lecture, class 12, we essentially have talked about the research note 2. We can let you date. Okay, there's a wrong due date in the research note instructions. Okay, so this time we talked about mediation. Are there any questions on mediations? Have you had time to look into the code already? Have you had time to look at mediation?
No, I haven't, Professor. I haven't had time.
Okay. So
yeah, not in
okay.
not in so much detail. I was actually looking at 8 and 9 today, the
okay.
classes and the labs, and I had a question from class 8.
Okay.
And it's
Mhm.
and it's on the 4th slide in class 8.
Yeah. Let me quickly put it up. Let me see the PDF.
Yes, I can see it,
Okay.
Professor.
Okay, slide 4. This here? Possible
Yeah,
analysis for, yeah.
yes. So in example 3, it's asking is the 2-sample t-test appropriate? And yeah, I was just looking for a further explanation of that question. I know in the lecture it said that it wasn't appropriate, but I wanted to know a little bit more about why.
So the context here, essentially, we are looking at, so we have 3 different ways, right? So we have binary outcomes where we have basically these are predicted by either a binary outcome or a categorical variable. So the problem why a two-sample t-test is not appropriate in exclusion, because the relationship between the log odds and the probability is logarithmic. So this difference needs to be seen on a logarithmic scale. So only doing a 2-sample t-test would not sufficiently establish this association with the probability of an outcome. So you can say that it essentially it suggests an association, but if you really want to model it and quantify the odds ratios, you would essentially need to relate your continuous variable to a log scale probability of that outcome. So it's not appropriate to essentially use it for this purpose, right? But essentially, you are having with logistic regression as binary outcome, you have already quite a good insight that there's a difference with a t-test, but it's not enough essentially to just establish causality or establish an association for this. Does this address your question, or what specifically are you interested in this context?
No, that pretty much addresses it.
So you really you mean to model, you mean to model the odds of an event to happen versus an event not to happen. So to only compare this with a t-test is not giving you really the odds of this event to happen, right? You still can say that the continuous variable is essentially different in one group versus another, and you get an estimate of that difference, and you get whether there was a significant difference in those that had an outcome versus those that did not have an outcome, but it's not allowing you to quantify the odds and the probabilities of an event to happen. So it's a different approach. So it's not giving you that insight that you mean to have.
Okay, I got you, Professor. Thank you so much.
You're welcome.
Yeah.
So you're really meaning to relate it to the chances of the probability of an event to happen, right? And this is where it basically comes down to model this as in a Bernoulli distribution. So that's a good question. It's a very fair question. So you really want to get to this association where you essentially model the probability of an event to happen over the probability that the event is not happening, and basically establish this in a relationship between your log odds and your essentially probabilities. So that's why a t-test alone would not be sufficiently giving you insights. In addition to that, logistic regression, as opposed to the t-test, you can also amend and adjust for additional confounding variables, which you couldn't do with a t-test either. So it would be, it's much more versatile to essentially model it. But it comes down to the same question essentially when you have linear regression, right? You can hypothetically, a t-test could also be so you basically you have a relationship between a linear regression and the t-test if your t-test is basically an independent variable. So now the argument being, and this is what the question here implies, is whether you could just get the same insights of a significant difference in your continuous variable, but just comparing your continuous variable as per the outcome. So you would basically stratify as your outcome and use the outcome to stratify your continuous variable. And this would not be sufficient in the greatest realm of things. With a linear regression, you could do the same. You could include categorically your binary variable as an independent variable, and then get a difference, and thereby kind of get the same insights of the differences between the two groups, as you would do with a t-test, for example. But again, it's not giving you odds of an event to happen versus not to happen. So I hope this kind of addresses your question sufficiently.
Yes, definitely.
All right, good. Then we have essentially for class 12, we have the mediation example. And I encourage you to watch the recording and maybe come with additional questions tomorrow if you have any questions on the lecture. If not, I would also kind of recommend to really go through that example that is given in the RMD file. Where is it? Chrome. Oh, yeah. So here, basically, you have a very nice explanation of what the R outcome essentially means to simulate here. So you want to quantify the likelihood to be pollinated by a bee, and you're looking for the iris example, and you basically mean to compare the relative effect of septal length and septal width, and petal length and petal width to a likelihood to be pollinated by a bee. So essentially, you take the iris data set, which is one of the included data sets in R. You basically create a random variable, which is here the variable, the attractiveness of a bee, which is basically any other form of attractiveness, like the location of this flower, etc. Everything that may make the flower more attractive to the bee to pollinate it. And then you're basically creating this as a so-called mediator. and you're creating this this mediator as a function of septal length and this random attractiveness, this unquantified random attractiveness. So it's just a simulation. So, but you come here and in the same fashion, you create a second random variable that you use then to create your dependent variables. This is what you do here. So the likelihood to be pollinated by B is 35% by the mediator and 65% by the random noise by your mediator. So essentially you create this dependent variable, which is your outcome. And then you're seeing in this step, you fit the total effect as a function of the septal length causing the dependent variable to be pollinated. And you find this log odds to not this association, this effect of septal length on the outcome of being pollinated, likelihood of being pollinated. You go then on to essentially establish the mediator, this error here, which is the direction or the effect of the septal length on the mediator attractiveness of the bloom to the bee. You're establishing this with the fit mediator that gives you essentially the second linear regression model with here an estimate of 0.3. And then thirdly, you're building the whole model and you get this fuller total effect. And you basically get the dependent variable, the likelihood of being pollinated by a bee, as a function of septal length and the mediator. And that essentially gets you these aliquot effects of each of those. Now with the mediation package, you can basically build here now a full mediation analysis with a bootstrapping function. So you're basically bootstrapping that. Bootstrapping essentially is an iterative replication of the same process with random subsamples being drawn from the same sample. Basically repeats this iteratively and gets you here the ACME, the ADE, and the total effect in an aliquot fashion. And then it gets you a proportion of that effect that is being mediated as opposed to that effect that basically is directly affecting your total effect. So basically the total effect is the sum between these two components. So this is the mediated effect and this is the direct effect. So you get basically with the mediation analysis, you get these broken down in respective subplots. So this is essentially that example that is being part of the assignment. This is close to it. And allows you to essentially answer this question here. So you can now run this analysis in the same fashion as it is being shown here by Matthew Fox. And essentially you can see these additional factors, and then you can, in an additional step, you could hypothetically also add additional confounders to your analysis, where you basically add here with the petal width. So you add petal width to your total effect, and you can basically add all of these confounders in addition to those. And then you can compare your results. Let's go through that. So this would be, again, random 1, random 2, gets you here the mediator. So now we are establishing that again. So now here we get the dependent variable, and again with the mediator, we get here a total effect. We get a note. We get now here larger numbers. We're fitting the mediator. And here we have separate length and mediator. And we can now compare. So this is now the initial one. Now we add two separate lengths, petal width. And we do the total effect. This is results one. So we have now our results one. So now we add separate lengths and petal width. We're getting a fit mediator again, which is just a temporary insert. Now we have the fitting of the dependent variable. And here we are now building our results two, which includes now our confounder in addition to that. Because to be the bootstrapping, this takes a little bit. But essentially it's nice to see then how these compare to each other. Show more of this on one slide. Okay. Now we can basically compare our total effect, which is here stronger because we're including, in addition to that, the confounding factor, where we see the direct effect is comparable, whereas the mediated effect by both variables now is essentially larger. The proportion of mediated essentially has now increased. That's just a very interesting insight into mediation analysis and to what extent confounders actually do play a role, and how you can actually carve out the direct effect from your can be a treatment effect or whatever effect you essentially are interested in. So that was the example of Iris, which essentially was part of class 12. And well, any questions to that?
No, Professor, I don't have any questions. I'm still trying to digest this information.
Yes, it's easier, or hopefully easier once you've seen the lecture. We can discuss it tomorrow again if you're available at 7. If you have any questions after watching the videos and going through the lectures. Also, there's some literature included, and I also encourage you to really also go through the article by Matty Fox, who essentially is really nicely outlining what is being done and why this is relevant. So it's essentially, so you have here a direct effect and you have here a mediated effect. So this essentially gives you a tool. So with mediation analysis and the mediation analysis tool provided for by R essentially allows you to carve out the direct effect and allows you to understand what part of your effect is essentially mediated by the main mediator and by a potential confounder, which is also additionally taking away, proportionally taking away from the direct effect. So, well, save your questions for tomorrow. In case there are any questions tomorrow, we can talk about this tomorrow. Any questions to anything else, to the research note or to the homework? Well, the homework is due on Sunday. Please make sure to submit it in a timely fashion. And if no further questions, I think we can conclude for today.
Sure. Thank you, Professor.
It's good.